Hi, it's Bill Grosser, the School of Ice and the U.S. Ice Drilling Program. I'm here for episode 3 of Abrupt Climate Disruptions. And today we're hiking in Northern California. We're at the very top of the Sugar Bowl Ski Resort. Beautiful place on a beautiful October day. The only problem is it is October, end of October, and we're having a record warm day today. At the end of a record warm month, at the end of a record warm year. And if you can see in the background, you might be able to see off in the background the smoke from our record number of wildfires this year. All things that point to abrupt climate disruption that's happening right now. So that's what we'd like to talk about in this episode. If you remember in episode 2, Dr. Osterberg took us through evidence that if you change the Earth's atmosphere enough, you can change the climate. And the evidence that he took us through was this event in 1800s where a volcanic eruption put so many sulfates in the atmosphere that it actually changed the composition of the atmosphere, and we had global cooling for a couple of years. Luckily for us, the atmosphere washed those sulfates out, and the atmosphere once again warmed up to what had been historical normal for hundreds of thousands of years. Well, in this episode, episode 3, what we'd like to look at is a couple things. We'd like to look at the abrupt climate disruption that we're living through right now as a result of all the fossil fuels that we've burned as humans and the amount of carbon dioxide that we've pumped in the atmosphere. We have actually changed the atmosphere enough that now we're seeing an abrupt climate disruption from changing the atmosphere. After we look at that evidence of the carbon dioxide, and we'll pull that evidence from the ice. After we look at that, what we'd like to do is look at some of the global systems that are starting to experience drastic changes. We'll go to Greenland and look at the ice there and see what kind of drastic changes are taking place in the Greenland ice sheet that are going to affect everybody on the planet. And last but not least, we will actually look at some creative ways that you can communicate with your friends and family the urgency of the situation and what kind of a situation we're in. So we'll look at creative ways that you can talk to them about what changes are taking place, and then also maybe what changes we need to take as members of this global community to head off the worst of the abrupt climate disruption that we're starting to live through. So that's where we're at today. With that said, let me change locations here and we'll start with episode 3. So here's what we'd like to start with. We'd like to start by looking for evidence that suggests that we humans are actually responsible for this abrupt climate change that's taking place. If we go to the ice cores in Antarctica and if we go to the ice cores in Greenland, we can actually look at the trapped atmosphere from all the way back to 800,000 years in the past. And we see some real definite patterns in that. If you look at this carbon dioxide data for the last 800,000 years, you can see the carbon dioxide in the atmosphere has naturally cycled between about 180 parts per million at the low end, up to about 280 parts per million on the high end. And what's interesting is two things about that. First of all, every time the carbon dioxide was low, around 180, that's when we went into these global ice ages. Every time the carbon dioxide was about 280 parts per million is when we went into an interglacial warm period. Kind of like we've been living through in the last 5,000 years or so since modern civilization has evolved. That's been a warm interglacial period. Well, if we look at what the data suggests that what we're living in right now is completely not normal from what's been happening the last 800,000 years. If we look at where carbon dioxide levels have gone to, you can see now they're all the way up there at 415 parts per million. So remember, normally it's been 180 ice age, 280 warm period. Now we're up over 415 parts per million. That's all that has happened in just the last 200 years since we've started burning fossil fuels, that huge spike. So there's the first piece of evidence. So what we'd also like to do is look at, okay, what kind of evidence are we seeing on these global systems? So let's look at two things. Let's look at land, let's look at the oceans, and let's look at them both together. And if you look at these temperature graphs, it's pretty obvious what's happened. We're kind of reached a tipping point where some years in the past, we had warm years and cold years, warm years and cold years, both in the land and in the oceans. But right now you can see overwhelmingly, we've had record high temperatures in the ocean and record high temperatures on the land. So it does appear that these carbon dioxide levels that we've cranked all the way up to unheard of levels are now starting to show up in these global systems like the land and the ocean. So it does look like when we look at global temperatures in the air and global temperatures in the oceans that we are seeing evidence of an abrupt climate disruption. So let's look at some of the other big global systems. How about these big global ice systems like the Greenland ice sheet? The Greenland ice sheet has the potential to affect billions of people as it melts and raises sea levels. So let's see what scientists are doing as they study that. Over the past 50 years or so, scientists have taken an incredibly detailed look at the Greenland ice sheet, and they measure in something called the Greenland ice sheet mass balance. In other words, they measure the total mass of snow falling on the ice sheet every year, turning into ice, and they measure the total mass of how much ice melts into the ocean. And then, historically, that's been in a balance, hence the name, the Greenland ice mass balance. Their data looks like this. If you look at all these different images of Greenland, it's kind of confusing. They divided Greenland into these different areas, and they measure how much ice is accumulating and melting in each one of these sub areas, then they add them all together. When they do that, they start to generate different graphs that look kind of like these. Well, these, maybe you can start to see some trends when you look at all that mess of graphs. You say, ooh, it looks like maybe there's a trend where most of them are falling off to the right, but that's still a really confusing way to look at things. So let's look at the Greenland ice mass balance as a running 3-year average for the entire ice sheet. And if we do that, you end up with these data points that go up and down as a 3-year average. And until about 1996, they show a pretty nice, some years are gaining a little bit, some years are losing a little bit, gaining a little bit, losing a little bit. 1996, though, it seems like that 3-year trend kind of drops off. So if we draw a best fit line through that, through the balance at the top, and then where it starts to fall off, it even becomes more obvious and it becomes a little bit easier to see what's going on there. So the only problem here is that this 3-year Greenland ice mass balance is measured in something called gigatons per year. Well, I'm not sure about you, but I like to ski here at Sugar Bowl. I'm not sure what gigatons per year really mean. So if you're going to have meaningful conversations with people about how much ice Greenland is losing, we need some units besides gigatons per year that make more sense. So what we do is let's bring Layla back. Layla's going to come back for a Zoom minute. She's going to take us through converting these gigatons per year into a unit that's much more meaningful. So let's turn it over to Layla.
Hey everybody, welcome back to Layla's Zoom Minute. Today I'll be discussing how we can get those massive measurements we've seen into more understandable units so we can talk to people and explain the climate crisis in a more understandable and digestible way. So we've already seen that humans are causing this abrupt climate crisis, and one of the measurements that we've been using for this is Greenland's ice mass loss per year. And we measure that in gigatons of ice. But gigatons of ice are very large and very hard to understand, so what if we use a different measurement to make this more understandable? What if instead of gigatons of ice per year, we use something like elephants? Maybe even elephants per second. So our goal is to get gigatons of ice per year into elephants per second, and the way we would do this is to use the ice to elephant conversion factor. So our first step is going to be figuring out the equivalent units for everything that we need in this ice to elephant conversion. So 1 year is 31,540,000 seconds. 1 gigaton is 1 billion metric tons, and 1 elephant is 4.3 metric tons. So now that we have all that figured out, let's go ahead and set up this problem. We have our initial, the 1 gigaton of ice per year, but then we have 1 year over the amount of seconds that we want. We have the amount of metric tons, 1 billion over 1 gigaton, and then we have 1 elephant over the amount of metric tons. So when we multiply and divide this out, we get 7.37, but just to double check, let's go ahead and cross out all the units. The years cancel out, the gigatons cancel out, the metric tons cancel out, and we're left with elephants and seconds. So we know it's 7.37 elephants per second. So now that we have that conversion factor, let's go ahead and imagine this. So we already know our model, 1 gigaton falls into the ocean per year. Now let's imagine it with these little elephant guys. 7.37 elephants per second, per every minute, per every year. This amount of huge mass is falling into the ocean. So when we're talking to people and trying to explain just the scale of this climate crisis, it's always helpful to see or to use something tangible like elephants to better explain just how ginormous all of this change truly is.
Well, thanks, Layla. So now we have a conversion factor that we can use to convert these gigatons per year of ice being lost on the ice sheet of Greenland into something much more meaningful, elephants per second. And 1 gigaton per year of ice being lost on Greenland is the same as 7.37 elephants rushing into that ocean every second. So let's use that new conversion factor and let's convert our data that the scientists provided for us in gigatons per year into this more meaningful unit of elephants per second. So let's look at the years 1980 all the way down to 2015. And let's make a data table to record some data. I'll show you 2 examples and then we're going to pause the video and let you work on your own to finish out the rest. Let's start by looking at the year 1980. If we look at the year 1980 and go up on the graph until we hit our best fit line and then go over to the gigatons per year, we see that in 1980 it looks like we're losing about 20 gigatons per year of ice. So if we convert that using Layla's new elephant per second conversion factor, our 20 gigatons per year will get converted over to about 147 elephants rushing into the ocean every second. That's every second, every minute, every day, all year long. Amazing. So let's look at a second example. Let's go on our graph out to the year 2015. If we go out to 2015, go up to the best fit line and then go over, I estimate it's looks to me about 350 gigatons per year of ice. Let's do a little math. If we take that 350 gigatons per year of ice, multiply by Layla's conversion factor, 7.37 elephants per second. In 2015, it looks to me, according to my estimate, Greenland was losing about 2,580 elephants every second of ice. That's a lot of ice. So we're going to pause the video next, and what I'd like you to do is with your calculator and in your notebooks, I'd like you to take all the other years that are missing there, 1985 through 2010, use the graph of the best fit data, figure out how many gigatons per year it was losing, then use Layla's conversion factor, and can you convert all of those over to elephants per second? Go ahead and get that done, and we'll be back with you. Hey, welcome back. Hopefully you got all those conversions done, your calculations done. I can show you what I got. It might be slightly different than what you got because we're all estimating off that line. But here's what my data looks like for those years. We should be in the ballpark together. And now that we have that data, what I like to do is put it on a graph because a graph tells a story. So in your notebooks, let's lay out a graph. And we're going to start in the year 1980. We're going to go all the way out to 2015. Then the other thing we'd like to do is plot how much Greenland is losing. This time not in gigatons per year, but we'd like to plot it in elephants per second. We'll start with 0 at the top. Since it's losing, we're going to go all the way down to those negatives and build it all the way down to, let's go down to 3,000. So once you get your graph laid out like that, pause the video, take your data that you converted, put it on the graph, and let's see what that line looks like. And we'll be back with you when you're done with that. Hey, welcome back. So now you should have your completed data table and your completed graph, but now your graph is in elephants per second being lost from the Greenland ice sheet. That graph tells a really nice story. So what I'd like you to do is, next to that graph, somewhere in your notebook, can you write down 2 things that you notice about your graph and 1 thing that you wonder? So again, in your notebook, 2 things you notice, 1 thing you wonder. Go ahead and pause the video again. After you get those things written down, hit play again, and we'll wrap things up. Okay, so thank you again for joining us on our 3-episode journey to look at abrupt climate disruptions. Remember back to episode 1, Eric showed us how evidence from the past can actually be a window into our climate future. In episode 2, we looked at these volcanic eruptions that happened back in the 1800s and evidence that the sulfates that they put into the atmosphere actually changed our atmosphere on a global scale, and that changing the atmosphere actually changed our climate. And now in episode 3, we've looked at evidence that we are now the cause of this climate disruption. The carbon dioxide that we've put into the air is now having measurable effects on our atmosphere, our oceans, and our ice sheets. So thanks for joining us on those 3 episodes. With that said, I'm going to turn it back over to Eric for a few final thoughts. Thank you again.
Thanks, Bill. Can you guys believe how fast Greenland is melting? I mean, I don't know about you, but I just think about those 2,500 elephants just charging into the ocean every second of every hour, every day, all year long. I just imagine myself in the middle of them as they charge on by. It's just mind-boggling. And to think that even just back in the 1950s, there were 0 elephants charging into the ocean from Greenland. The Greenland ice sheet was in mass balance. There were some years that, grew a little bit and some years where it shrank a little bit, but it was in balance. So this change has happened so quickly. And of course, all that water is just rushing into the oceans, raising sea level, which is a huge problem for cities all around the world that are on the coastline. And as Bill said, I mean, these days we see evidence of human-caused climate change literally everywhere we look. Bill mentioned the record wildfires that we've seen this year in California and Colorado. And we just had the 27th hurricane or tropical storm form in the past year. 27th. I mean, there were so many storms that they literally ran out of letters to name them. And that's only happened 1 time before, in 2005. And we're on record to beat that year in 2005. It's just amazing. And this is after all of these devastating hurricanes that we've had hit the United States just in the past few years. And what scientists have said, they have proven that those warmer oceans that Bill talked about, those warmer oceans are the key reason why we're seeing so many hurricanes these days and why so many of them are so powerful and devastating. So it's all connected to those rising greenhouse gas emissions from human activities. And closer to home for me here in New Hampshire, right now it's just a stunning day in late October, kind of a crisp day. But we just came out of the hottest summer on record. That's in southern New Hampshire, Massachusetts, Connecticut, and Rhode Island, all the record warmest summers. And that warmth caused extreme drought for right here in my home and pretty much that whole region of New England. I mean, we've been worried all summer that our well's gonna go dry because that's happened to some of our neighbors. And again, this is exactly what climate scientists predicted would happen as human CO2 causes the planet to get warmer and warmer. We would expect to see more of this summertime drought conditions in places like here in New England. And now here in New Hampshire, as we head into the winter, the big question on everyone's mind is, what is this winter gonna look like? Are we gonna have a lot of snow and a good ski season? I mean, snow and ice skating, skiing, snowmobiling, that's a big part of the culture around here and a big part of the economy. And as fast as our summers have been warming around here lately, the winters have been warming even faster. And I really start worrying that, my kids aren't going to be able to enjoy winters in New Hampshire the way that I did. And what about my grandkids? What's it going to be like for them? And remember that ski area out in California where Bill was reporting from? Well, a report came out just last year. A bunch of scientists said that in 50 years, there aren't going to be any ski resorts left in business in California. It's just going to get too warm. So these are the things that I notice as a climate scientist as I look around at how quickly the world is changing around us from human activities. And one thing I wonder is, when are we going to start doing something about it? This rapid climate change that we're seeing requires abrupt action. We have to start now. And as I start thinking about all the things we've talked about with the hurricanes and the droughts, and as I think to the future, I'm not actually depressed about the future, and I'm not scared about the future. I'm actually excited to see how we rise to this challenge. Because there's one thing I know for certain. We created this problem, so we can fix it. And so I say, let's get to it.